Thanks. Okay, let's get started. My name is Ken Whitaker, and I'm presenting a two-part dialog box class. And this first part will take about 40 minutes. And then the second one will actually be a little bit shorter, around 30 minutes. I found that dealing with dialog boxes is, I can't say anything funny about it because it can be a lot of stress dealing with it and figuring out how to do it right. Most Xojo desktop apps, for example, and that's what we're going to be talking about primarily, present and retrieve information in dialog boxes. So this is pretty much a beginner's class to like intermediate, and it gets further into complexity as we go into the second part. My experience with working with dialog boxes is it's very easy for them to for your code to become spaghetti code if you try to do a lot of activity and like interactions between controls. And so I figured, good golly, there's got to be a better way to do it. And so what this is basically a structured approach towards building dialog box code. So the training goals for this morning is that although dialog boxes can be simple, the interactions between objects in that dialog box can take some effort. The first thing you want to do is write code that is maintainable for the long term, so that you don't, when you go back and try to fix something, I have no clue what's going on. Second is you need to make it usable for the end user. This is an example from Photoshop, from Adobe Photoshop, where I've highlighted some of the characteristics of a dialog box. Number one at the bottom are the dismiss controls buttons, and as you all know, they're different between Mac OS and Windows. Second one is coloring. Most of our dialog boxes are pretty plain, pretty boring looking, pretty gray, and so wouldn't it be nice to use some sort of coloring scheme for all of your dialog boxes? Third is the language. Not everybody speaks English, and so you need to consider that. And of course, customized controls. Number four, images and all sorts of other things. So that's basically what we're going to do, is talk about how best to manage all that stuff going on within a dialog box. As I mentioned earlier, we're going to step through the concepts and build up from one example to the next. We actually have 6 core examples of dialog boxes. This is a roadmap for this morning. The first one is to go through the anatomy of a dialog box. Second is to create a simple message box. Third is to create a basic model to display information in a dialog box. And the fourth is to add pizzazz with eye candy in the dialog box. At that point, we'll have a break. And then following that, in the next session, we'll do a interactive modal dialogue handling, some real neat activity between the controls and how not to get lost in them. And then the final one, which is topic 6, is regarding in one set of dialog box code, handling both modal and modeless interactions. So, you all ready? Okay. Don't you have somewhere to go, Tom? Oh yeah, I forgot. Okay, so this we'll do the session now, and then in the second one, the advanced topics. So the essentials. This is our step 1. From a highlights, a dialog box is a temporary window. It retrieves user input as well as recognizing information to the user, optionally prompts for additional information, and there are 3 basic types: the modal, system modal, and modeless in terms of how dialog boxes can be instantiated. In Xojo code, and by the way, we're going to switch into Xojo code, but I'm not going to walk you through step by step by step. of code after code. So, and this is all available for download at the end of the day from the Xojo website that you'll be hearing about. The first item there, of course, is the UI-like elements, the UI design, the layout of the dialog box. Second are all the controls, those smart objects on the dialog box on the window. Third is event handlers that takes handling of events that are triggered. And fourth are, of course, methods, and we're going to take a lot of advantage of methods within a dialog box, as well as local properties that are used while that dialog box is being used. So, basically a dialog box acts as an object with the UI attached to it. Now, in terms of roles and responsibility, there is a caller role, where that is basically the logic that calls the dialog box. It usually passes information to the dialog box. It also can retrieve information from the dialog box, and it also manages the program flow based on what the dialog box usually presents or gets back. Sometimes it doesn't, but oftentimes it does based on what the user wants to do. Within the dialog box, you keep the user-like interactions like away from the caller. So the caller doesn't really know what is going on within the dialog box, typically. Also, it takes care of the nuances of the platform. Like I said, I'm going to be talking about the slight differences between Windows and Mac OS, as well as it's designed to be invoked from many callers, meaning that dialog box may have different caller logic that like invokes it. So the dialog box really doesn't know who's calling it or why. So another way to depict that is through a hierarchy, is that the application that starts out actually can become the caller or actually calls another win main, for example, in Xojo, which will then itself call dialog boxes, and then the dialog box logic. And the idea is you just call down to it and you pop back up. That's typically the way that things flow. So we're going to concentrate a lot on what's going on within that dialog box. So your first simple message box, I know this is ridiculous to show you, but I am. I have a main window app, and it'll have a single button on it that you hit go, and then of course the quit button when you're done. And when you hit go, the message box is displayed. On Windows, that's what it would look like. On Mac OS, it would look different, but the same idea, it's the same code. If you look at it from a who's doing what along this hierarchy, the caller will invoke the dialog box and will automatically be suspended. When the dialog box is properly dismissed, it is then returned, and the caller resumes. This is an example of code that could be used to invoke that. For example, you present a message box. This is a simple message box with an OK button, and you all have seen this before a million times, I'm sure. It's pretty simple. And you know, I would show you how a message box looks like, but I think everyone here in this room knows, so we'll probably spend more time with the next one. Okay, creating a model to display information. I really enjoyed Phil's presentation yesterday on factoring your project for testability, because he introduced the whole idea of model view controller, and we're going to work on that also starting now. What we're going to do is we're going to add a public call, a public method within the dialog box called WinDisplay. And again, the way you would implement all this may be different, but the whole idea, I'm hopeful that you'll get some ideas of how to structure your code. We would introduce helper private methods, and I've named them initUI, loadUI, and unloadUI. And then setters, which saves past information into the dialog. And then later on, we'll talk about getters. So this is an example of where the dialog box logic would actually, when you hit the go button, would display the information being passed, and that's what it looks like on Windows and Mac OS. If you look at that same hierarchy diagram, it's very similar as we did before with the message box, only this time we're going to be passing more information to it. With regard to setting up the dialog box properties, I wanted to highlight these are the settings that I found works for both Windows and Mac OS. And again, there doesn't need to be a minimize, maximize, and full screen button or resizable. So that's pretty much it. To invoke this, it's very similar to what we did with the message box, only this time when we're instantiating the dialog box object and then like calling the win display. And I'll show that code in just a moment. So again, that's that code that up in the caller is invoking the dialog box right there. And this is what WinDisplay does. It actually saves into local properties the information being passed. In this case, there's a text message, and then there is a title for the dialog box. And there are two functions in there called the init UI and load UI that are automatically called. And in this case, they really don't do a whole lot, but they'll show more as we go forward with these examples. And then the WinDisplay does a show modal, which actually displays this to the user. Any questions so far? Okay. The init UI, oh, that's the go button. Okay. Okay, I want to show this, how it works. And this will be on Mac OS. Of course, it went to the other screen. There we go. So that's the message that's shown. You dismiss it by hitting OK, and you can quit that at that point. So boom, it's gone. And I wanted to show you the code. All right. Hopefully you all can see that. This is the controls. There's not much happening there, except for the done. When you hit quit, it basically, we've added some helper functions. These are private functions within the dialog box logic. In this case, the helper function, helper done, unloads what is in the controls, if there was any information in the controls. In this case, there's not. But you get the idea that if there was something, text in a text box or some sort of other checkbox item or something, this is where you would unload it. And of course, there's the WinDisplay function right there. So you get the idea of how simple that structure is. And if you look at the properties, the main goal here is when you initiate the dialog box logic, you immediately save that information that's being passed into a properties. You do this because if it ends up changing, and it doesn't in this example, but if it ends up changing, you can then keep it there locally within the dialog box. Yes, sir? Oh, well, I'm not sure how to do that. Sorry about that. Anyone? Oh, wait. I think you can do. Is it control zoom? I don't know. No. Sorry, I don't know how to do that. Okay. As well. Sorry, guys. In the keyboard? Zoom to enlarge the screen. Boy. There we go. Okay, thanks, guys. Wow, cool. Let's see. Awesome. Okay. So you get the idea of what's involved when the WinDisplay function is being called. And again, first thing it's doing is it's saving the past information locally. It's initializing the user interface. It's then loading the user interface, and then it shows itself as being modeled. So this is the basic structure. Now let's see, how do you get rid of that? Okay, neat. And then that's about it. Okay. I think, there we go. Okay. What's missing? There's a dull, the color is horrible to look at. I mean, it's pretty plain. Not everybody speaks English, as I mentioned earlier. We need to hide the nuances between the platforms. And we need to stop multiple instances, because I want to show you all something. If I run that app, let me see, I hit go. There it goes. I hit go again. Have any of you seen this? Maybe you don't know it, but every time you hit go on the caller's screen window, for example, you'll be re-invoking your dialog box. So you may not even know that your app has that feature in it. And we don't want that, right? So.
Does it have to depend upon the window selection? If you chose a mobile window as opposed to a floating window, you can't have two mobile windows on top of each other?
I'm not sure. Maybe so. Maybe so. But I wanted to let you all know that if you double purpose your dialog box code for modal and modeless, for example, you want that level of flexibility, which we're going to show you on the second session, you need a way to protect that from happening. So, okay. Okay, let's add some pizzazz with some eye candy to this app. We're going to apply color, configure a look and feel. We're going to also have language-specific text in there, platform identification, where we're going to determine the platform, and then provide an instance counter to protect the dialog box from being invoked more than once. So here's an example of some coloring that could be used, for example, to make those screens that I showed you earlier a lot more lively, a la what you see in most modern-day apps. Also, there's some rules of engagement from what needs to occur externally by the caller and then internally. And it would be nice for all of your dialog boxes to be able to access the same set of common services that we are going to provide up in the app from anywhere. For example, if you have a color setting for your dialog box, you don't want to do that code in every dialog box code's logic, right? You'd like it simple. So this is, we're going to do that again. Okay, not sure how to scroll that, but okay. So here's an example of public methods that we have added that are accessed within any dialog box that we're calling. And one of them is called getColor. And this is where, as you see from the parameter being passed, you would indicate some sort of a identifier, meaning like, in this case, the background color, and you would return a color as a result. And you could have label color, you could have text color, you could have all sorts of things like that. So this one method would be at the very top of your app to be accessed within dialog box code. So those are the methods. We have a fwin invoke, which basically protects a dialog box from being called more than once. We have a getColor that, as I said, handles the color. And by the way, this information here, we have it as a select case statement. This could easily be read in from a parameter file of some sort, where the user or whoever could change color outside of the app completely. Or it could be set by the app and saved out there. Yeah, right, right. But, oh, the question was you could save it within a property within the dialog box. So it's more of a statement. So what I like about this is that this could be configurable if it was external. And if it was read in from some parameter file or plist or something like that, then all of a sudden it was made accessible for all your dialog boxes. Get language text, we're going to talk about that in a moment. And of course, if Mac or like otherwise Windows, in the case of the desktop platforms. And then the opposite of the fwin invoke that protects multiple instances of the dialog box from being displayed. Obviously, when dismiss is the opposite, meaning that dismiss it. So the get language text, this is an example of yet another select case. It's kind of rudimentary, and just for this workshop this morning. But there are alternative ways to put in language, of course, the same way that you were saying, Tom. You can do it that way, or you can use lingua. There's all sorts of techniques to do it, but I did want to show you. Anytime you display text, you probably want to get that text based on the language of choice. And if there's a way, like in lingua, where you can send out that file to professional translators, even better than trying to do it yourself. So this is an example where there are, once again, descriptors for specific text that's going to be displayed within a dialog box, that you send that descriptor up to this public method, and it returns what it is based on your language. Again, this is a very simple view of how to pull that off. And of course, like I mentioned, lingua you could use, and as Tom was probably going to tell me here, you could put it within the variable. Also, the fwin invoke and the when dismiss. I want to take a moment on this. With fwin invoke, it basically uses, guess what, a descriptor again, where you would identify the dialog box with a unique name. And in this case, before invoking that dialog box, you would then just call this routine. This would return a true or false. It returns a false if it's already, that dialog box is already displayed, and a true if it's not. So that kind of thing. And the dismiss does the opposite. So in this case, what it does is we're just setting a flag specific to that dialog box. So the next time you would call fwin invoke and you already have it displayed, hey Mark, I don't think we're going to need to show it. So if you're going to show that, if you're going to display that dialog box, you would always call F1 invoke just to make sure that it's not already up there. And it's good. It's a good rule to make sure of that anyways, I think. With regard to the action, this was what you would use. This is what it has changed to, and I think it's a little bit hard to read now. Where you would call F1 invoke with that descriptor for that specific dialog box. It would come back and say, if it's true, then great. It's not being used, I can call it. And you, like before, you instantiate the dialog box object. You call WinDisplay with the past parameters. And in this case, look, there's something a little bit different. This time, we chose one of those public methods. Whoa. All right, thank you. So in this case, there's the app.getLanguageText dbox.info message, and then the app.getLanguageText for the other text. So this is where you would go back and say, okay, give me the local language equivalent of what the dialog box needs to display. And then WinDisplay, of course, starts up the dialog box, and when the user dismisses it, it returns back, and what you immediately do is to call the public method WinDismiss, which basically says that dialog box can be called once again. Any questions about that?
You have to do that every time you use this dialog.
Right. Just to keep it straight if you don't want multiple instances out there. That's weird. Okay. The way I laid out the dialog boxes is I put funny text. Oh, I know. This presenter actually has a mouse on it, so it's getting mixed up. Okay. The dialog box layout, which I'll show you in just a second, actually has pseudo text in there. So so I always remember that I'm loading the language resource into that dialog box. And of course, that text is going to be overwritten. Internally within the dialog box, this is where the model view controller comes into, where the model is basically the local data that always reflects the current state of the data required by the dialog box processing logic. The view is updating of the UI-like elements as the user sees it. Then the controller is when a user or an event forces data change, the controller logic accesses the model data and can update the view. The controller is the brains within this logic. So another way to look at it is that this is how we did show it. And by the way, there's a mistake in all the diagrams with this. This shows basically local, when the dialog box is being called, the first thing it does is save the past parameters into local properties. That arrow needs to go the other direction. And in your handouts, I carefully drew that over. So that's my mistake, and you'll see it in every one of these. So I'm going to go to hell for that, I know. So this is a brief description of those dialog box methods. And I know you're going to say, bring it up. Okay. So the init UI is invoked by the WinDisplay function within the dialog box. And it updates the UI with information that doesn't change. This is primarily the static data, like labels, for example. The load UI is a more dynamic thing that is called by, once again, WinDisplay, generally, when you want to update the user interface. from the data model. The unload, as you would guess, takes whatever is in the controls dynamically, that has generally will change based on user input, and brings it back down. It saves it into those local dialog box properties. So the dialog box properties, once you do the unload, should always match what is the information kept in the dialog box controls by the user. And then there's helper functions that is basically shared logic among the functions within dialog box that makes it easier to maintenance the code. So here's a pictorial view. If, I guess I need to bring that up. The close button on the Mac OS, which is on the left side, and the close button on the Windows on the right, whenever you hit the OK button, it's going to call, the OK button is going to call a local helper function. We call it helper done. It will unload any user input and then properly then dismiss the dialog box back to the caller. Pretty simple. So it generally, and that's why it works regardless of the platform. So let's show it. Oops, okay. I think what I'll do is I'll just run it from here. So you can see now there's color. This is the information that is displayed. And when you hit OK, it goes back, and you can, it's coming up to the other monitor. And then if I hit OK, the Go button again, it doesn't let me do it. And if I look at the code, here we go. There's the F invoke that I mentioned that's publicly available to all dialog boxes. The get color, the get language text, also which operating system platform is it, and then the dismissal code that matches as the counterpart to the fwin invoke. And I use the fwin, meaning it returns a Boolean for those of you in the old Fortran and C days. I wasn't born then, but I read about it. And then this is what the Win app does. As you can see, it just invokes that guy. And then down in the dialog box, oh, I want to show you. There it is. So there's the title that doesn't make any sense because it's going to be overwritten. And what's good is when you do it this way, you can pretty much like assure yourself of language, of good language handling. If you still see some messages with a Z in front of it still on the screen, oops, you didn't bring down all the text that you should have. So that even goes for the OK button, so everything. And if you look at the code in there, you got the event handlers. It's just the close. Again, it's not too fancy yet. There's the helper done that I mentioned. It unloads the information in the UI. Let's go right ahead and look at that. It doesn't have any information yet. That's what we're going to get in our next session when things get a little bit more complex. Load UI doesn't, but the main thing is for static data, you call the init UI local function within that dialog box, and this is where you would call back up to get the proper use of the background color, the text color, and anything else like that. Also, you would also set a flag locally if this is a Mac OS, because you probably don't want to keep on calling to the operating system, are you a Mac, are you a Mac? Hell, do it once, and do it when the app starts. And I think we all should consider, like in the old real-time or the embedded days, anytime you talk to a physical device, like even a screen or something, try to minimize that. If you only have to ask for information once, do it only once. Keep your software running as efficient as possible. And here we're getting the language text for the button OK. And if I want to go back and look at that, there it is. When it looks up the button OK identifier, it returns the OK string. So that's pretty simple. So that's how that works. Okay. This is an example where anytime you could just put in a beep if you wanted, just to see if this dialog box is being invoked more than once. Go right ahead and beep, because this way when you invoke it from the caller, you would get a false response, a false feedback. Whoops, sorry. And then those are basically the pieces. So I know this has been somewhat rudimentary, but in the next session, it's about 9:40. We're going to meet again at 10 o'clock. We're going to get into some more complex things. For example, I just wanted to show you, I might as well show you this, an app that I built. Oops, sorry. Uses this stuff extensively. And what's interesting is, let me see if I can bring this up. Okay, you see that splash screen that's counting down? That is the same thing. That is the same dialog box code as the about box, showing different information, one set of code. So that's what we're going to talk about at the next session, on top of a few other things. And as you can see, the coloring and all that kind of stuff, this is all based on that same sort of logic, all driven from parameter files, all consistent among all of the dialog boxes. Okay. So that was basically the essentials part that we were covering this morning. And again, it's about 9:40. In the next one, we're going to talk about sharing code between modeless and modal dialogues and having a lot more like interaction between controls within that dialog box, just like I showed earlier with the Adobe Photoshop, the interaction that takes place. So let's take a break and see you all back at 10. Any questions, by the way? Okay.
Your next presentation as well.
Put all these reference routines like get color in the app object.
Right.
Why not put them in a module which you can export as an external?